Assalamualaikum and salam sejahtera everyone. Today our group will be present our project entitled Microbit RC Soccer Showdown Blitz Edition. This project combines epoxy resin material technology with a microbit control robocar. This project was carried out by Group F2. The group members are Anissa Nabiha, Nur Shazwani and Ilham. For introduction, epoxy resin is a polymer material that has high strength, durability and good chemical resistance. It is widely used in engineering fields such as automotive, aerospace and robotics. In our project, epoxy resin was used to fabricate the robocar chassis using the solution testing method. The sample was then tested to evaluate its property. The material and components used in this project include epoxy resin, curing agent, mold, mixing container, battery holder, jumping wire, microbit, wheels, crocodile clips and servo motor. For the methodology, first, 40 grams of epoxy resin was mixed with 20 grams of curing agent until the mixture becomes homogeneous. The mixture was left for a short time to remove bubble. Next, the mixture was poured into the mold and curing at room temperature for 1 hour. After curing, the sample was removed from the mold and prepared for characterization and robocar fabrication. Then, coding was developed using make-code microbit, followed by the fabrication of the robocar. Finally, characterization tests were carried out. Optical microscopy was used to observe the surface morphology, while tensile testing was conducted to determine the tensile stress and elongation of the sample.
Hello everyone, my name is Ilham. Today I will present the result and instructions of this project. We start off with at the physical testing for our epoxy resin. So we have conducted tensile strength using universal testing machine or UTM. As you can see in the picture, we successfully clamped 3 different samples, trusted epoxy samples, and stretched them until they are broken. Visual inspection of this sample confirmed that 3 samples have been fractured right in the middle of the gauge length, meaning that our test is successful. Okay, next we will look into the raw data collected from 3 different test samples that were previously mentioned. Okay, looking at the average, our epoxy sample sustained a maximum force of 175.50 newtons before failure. This translates to ultimate tensile strength of 3.50 MPa. The most interesting data here that you can see within the table itself is the strain at break. The sample show an average elongation of 94.63%. Okay, in addition to mechanical testing, we also conducted a surface morphology on our material using a microscope. We used 5-time and 10-time magnification shown here, which reveal that the polymer matrix generally appear well uniform and well mixed, which show that the cutting process that we conducted are successful and as intended. Okay, in addition to 5-time and 10-time magnification, we also use a 20 magnification, so we could see in more detail the internal metric structure. From what we can detect, there's several defects such as trapped air bubbles or pores that scattered within the sample. So moving on to the discussion section, let's look into the mechanical strength of our material. So our tensile strength yield an average ultimate tensile strength of 3.50 MPa and a maximum sustained force of 175.50 newtons. Because we specifically use the epoxy to fabricate the RC car front ram and outer bumper, having high structural strength is vital. These data prove that the ram and bumper are strong enough to withstand high physical force without bending, warping or cracking when hitting the soccer ball or defending our zone. Okay, so next let's talk about flexibility and impact resistance. This is where our material choice really benefit the RC gameplay. The testing showed an exceptionally high average strain at break of 94.63%, which proved that this epoxy composition is highly ductile rather than brittle. During the fast-paced Blitz Showdown that have been conducted, our ram and bumper will be constantly colliding with the opponent as well as both. Because the material is so ductile, the ram and bumper act as an excellent built-in shock-absorbent flexing slightly to absorb and dispel the collision energy instead of shattering upon impact. Okay, now let's connect this physical property to our microscopic finding. Our earlier results show some minor microscopic pores and trapped air bubbles at 20 magnification. These micro bubbles are just a normal consequence of manual hand mixing and room temperature curing. The key takeaway here is to is that despite the tiny above pocket, the material still achieve great tensile strength and incredible ductility. This proves that the minor mixing inconsistency did not compromise the structural performance of our ram and bumper during the match. So, to conclude the discussion section for my parts, our project demonstrates that simple room temperature solution casting is an incredibly effective, practical, and low-cost method for manufacturing custom parts such as high-impact attachment component like ram and bumpers, while manual processing to produce minor data variations between our test samples. The overall strategy was successful. Ultimately, this flexible epoxy composition delivered a perfect balance of load strength and crash-proof durability required to keep our RC car well protected and highly competitive in the match.
Finally, I would like to conclude our project. Next, I would like to explain our Sulam activities, which focus on knowledge transfer between students and our project. In this activity, we conduct a knowledge sharing session on basic robotics and STEM concept for students. The purpose of this session was to introduce robotics in a simple and easy to understand way, especially for beginners. We also perform a live demonstration of Robocar to show its real functions and operation. Through this demonstration, students are able to see how the robot moves and respond in real time, which helps them understand the practical application of robotics. In addition, we provide simple explanations of programming, concepts, sensor and control systems.